The problem that we are looking now is search in rotated sorted array. So there are many variants of this problem, like find a minimum in rotated sorted array and something like that. So all these fall under the same category. I mean, you can, with the minor tweaks, you can solve that. So let's go through the question. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. So if we have this array 0, 1, 2, 4, 5, 6, 7, it may become 4, 5, 6, 7, 0, 1, 2. So how they did that is this 0, 1, 2, they took it from here and added it at the end. So it becomes 4, 5, 6, 7, and this 0, 1, 2 which is added at the end. So this is rotated from there. And you are given a target value to search. If found in the array, return its index, otherwise return -1. So you can assume that there are no duplicates. And it should have an order of log n. So this log n, it indicates that you should have some efficient approach. Most of the times when searching in an array comes, you think, is it possible with binary search? So here if you see this array, they asked for 4, which is rotated from here. 4 is present at the 0th index, return 0. Here they've asked for 3, which is not present, so return -1. So let's see how we can solve this. So we'll consider a few examples here. So it's with minor tweak of binary search we can solve this. So I'll consider a simple example where I have 1, 2, 3, 4, 5, 6, and I'll rotate it about 2. So this entire 2 goes and it comes to the end. So this index. So from there I have rotated. So it becomes something like this in the second array. So let's see this later. So how we can solve this? So what I'll have is I'll have I here and j at the end, okay, and I see the mid element. So I got this as a mid element. So which is a standard binary search where I go for a start and end and I find the mid element. And what I have to do is, so when you find the mid, this divides the array into two parts, this and this. Sorry, I'll include this here and this here, okay, something like that. So among these two parts, one of the part will be sorted and the other will be unsorted. So how do you know which is sorted, which is unsorted? So I'll check mid and the rightmost element. So if the rightmost element is greater than the mid, so then this part is sorted. So if it is not greater, then the left part is sorted. Or you can even check with the other way around, like if the mid is greater than the leftmost, then the left is sorted, otherwise the right. In any way you find the sorted and the unsorted parts. So here I got that this left is sorted and this is unsorted. So once you have found that, and okay, let's say the element that you have to find is 4, or say I'll consider it as 1. Okay, let's make it complex. So I found that this is sorted, this part, and this is unsorted. So I'll check if this element lies in the sorted part. So first I'll find which is sorted, which is unsorted, then I have to check if it lies in the sorted part. So 1, is it greater than the, I mean the sorted part is at the left, right? So I'll check if 1 is greater than the leftmost element. So I'll check if 1 is greater than this and less than the this element. That is it in the left part? So it is not. So it is in the unsorted part. So now I go to this part and again recursively do the same thing. Go on doing it. So I'll go now. Let's see what happens in the other one. So recursively in the sense I'll discard this array and the same procedure that we did, we go here. So this becomes this entire thing goes away. And this becomes the new I, then this becomes a j. Sorry, so not this. I can simply go and put it here, I and j. So I do it in the other part of the array. Before that I'll check if mid is the same, yeah, target, and then go on doing, I go recursively left or right of the array. So now let's see what happens here. So I have I here and j here, so mid is here, right? So what I was checking is mid less than the rightmost element? So yes, then this part is sorted. So if I have to search for 3 or something, so I'll see if 3 is greater than this and less than this. So then yeah, then it lies in the right part of the array. So how I'll update is I'll update this I to mid, j I'll keep as it is, and again continue doing recursively on the right part, something like that. So let's write the code, maybe then we can understand it much better. Let's minimize this. So I'll have a function here which returns index and name it search recursively, and which takes the array, then the target, left and right. And if left greater than right, then I return -1. So this is a terminal base case of this recursion. So then I'll find mid. And I'll check if the mid is the target. Then I can return mid. So if mid is not the target, I have to check if right half is sorted, right? So how do I do? So if condition is satisfied, then we know for sure that right half is sorted. So otherwise, if it goes to else part, then left half is sorted. Okay, this I know that it is sorted. No, why question mark? So we know that right half is sorted, so we check has to be there on right side, because we don't know, we can't, there is no possibility of checking it on the left side, right? Because it's unsorted, we don't know the pattern. But right side is sorted, I can check if it is in the range of the right side. So how can we do that? So this should be less than nums dot. So they shouldn't go out of index, and so this target is greater than or equal to, so mid +1 and the rightmost side first element, and it should be less than the rightmost element or equal to at least. So then what I can do is I can call recursive. If this condition is satisfied, I can go on the right, recursively on the right side of this, right? Same nums array and the same target we are looking. But here I am going to the right hand side, so left I can update to mid +1, right remains same. So otherwise what I can do is, if it is not in the range of the right side, I have to go to the left side. So this will be left only, and this will be mid -1. So now, okay. So here we know that the left side is sorted, right? So I can check if element is on the left side. So there is no way to know whether it is there on the right side because that part is unsorted. So I'll check if the element is there on the left side. So let's copy this. So here mid should be greater than or equal to 0. It should go not negative, non-negative. and this should be greater than nums or equal to nums of left, and this should be mid minus 1. I can take it. So then it is on the left side, so then I have to go to the left side of the array. So this is left and this should be mid minus 1, left half of the array. So otherwise I should go on the right side of the array, right half, which would be mid plus 1 and right. So let's run this code. Okay, what happened here? Okay, yes, I can remove this. Let's run this now. Yeah, I simply can put a return here. Okay, I didn't put a return. I didn't write this main function in the main one. So this has to be nums target from 0 nums dot length minus 1. And now let's run this. Okay, we got the same one, so let's submit this code. Did we do something wrong? Okay, this mid minus 1 goes here, right? This should not be greater than equal to, but it should be greater than 0. Submit this. Cool, accepted, yes. If you like this video, hit the like button, and if you want to get more updates on the channel, hit the subscribe button and share it among your friends and colleagues and college mates and help us reach out more people. Thank you.